Welcome to the lecture series of digital electronics. Today we will discuss about demultiplexer. As we discussed the decoder in last lecture, some IC decoders are construction with the NAND gate. Since NAND gates are produced the AND operation with the inverted output, AND plus inversion, and it becomes more economical to generate the decoder minterms in their complement form. Most, if not all ICs decoder included the one or more enable input to control the circuit operation. Enable means if the circuit input is enabled, then and then it's work like as a functionality. Otherwise, the circuit is disabled and output is not according to the definition. Remember that thing, the all outputs are equal to 1 if enable is 1. Regardless the values of input A and B, when the enable input is 0, the circuit operates as a decoder with complement output. Now here, the demultiplexer, the demultiplexer have a standard one enable input. When this enable is logic high or logic low, then and then it can work like as an IC. So function is that enable function. And select input line. So it might be, suppose there is a 2 input n equal to 2, then the output lines are 2 raised to 2, 4 output lines are there. Okay, demultiplexer output have a same like as decoder, but in decoder the functionality is different. It decodes the output, while here the main input is enable. These are the like selection line, and the output is 2 raised to n. Suppose n equal to 3, then 2 raised to 3. 8 output lines are there. As per the selection line value, the corresponding output line equal to the input line. Okay, in one word, we can say that as per the selection line value, corresponding line is equal to the input E. If E equal to 1, and what is the binary decimal or binary value? Decimal value of this line with this line is equal to 1. Suppose in 2 n equal to 3, and if my input is 101, so this is equivalent to 4 plus 5, 5 in decimal. So fifth line, output fifth equal to enable E. This is as per the definition. A decoder with enable input can be function as a demultiplexer. Remember that thing. So let's see the circuit. This is the block diagram, or we can say that the pictorial view or IC diagram of demultiplexer, and it is always defined by 1 cross 2 raised to n, and n is the selection line. Okay, decoder, the difference is that in block diagram or in functionality, a decoder with enable input can be known as a demultiplexer. A demultiplexer is circuit receive information from on a single line. Okay, here the information is in single line, but where this information is going, it depends on this selection line. Okay, this called as the information. So information is only one bit. So suppose E equal to 0, 0. So it means 0. So whatever the information is passed to D0 line. Suppose my information is whatever the information, the A and B 0, 1. So what happened? Now whatever the information is passed to the line number 1. Remaining are open or not connected. Okay. Suppose the information, the selection line is 1 0. Then whatever the input, it passed to the second line. It is like as this is the short circuit. Okay, and the remaining all are open or not connected. And if the selection line value is 1 1, then whatever the information is passed to the D3 line and the remaining are open or not connected. Uh, Selection of a specific output line is controlled by the bit value of n selection line. The decoder can be functionality as a demultiplexer if enable is taken as a data input line and line A and B are taken as a selection line. We can vice versa, we can use this. Decoder can be replaced by demultiplexer, but the functionality will become changed only. If the single input variable E has the path to all four output as I have already explained, but the input information is directed to only one of the output line. The specified by the binary value of two selection line A and B value. And this can be verified from the truth table of the circuit. Let's see first the circuit diagram. Here, these are the selection line. So obviously, if I want to select the gate number 1, the value of AB is required A dash, and this one is the P dash. Okay, and E. So meaning is that if AB equal to 0 0, then D0 equal to E. Okay, here A dash is same, but the second input is B and this is E. So D1 is equal to A dash BE. When AB equal to 0 1, then D1 equal to E. So D1 equal to E, else D1 equal to 0. Okay, because it's an AND gate. In this logic only 0 and 1, then and then these two are 1 and D1 equal to E. Similarly, this is A and here B dash E. So when EB equal to 1 0, then D2 equal to E, else D2 equal to 0. And here it is A and B E. So we can say that when AB equal to 1 1, then and then D3 equal to E, else 0. So in this way the circuit is working. Whatever the input or information is passed to the output corresponding output line, which is select by selection line. Okay. So while all other outputs are maintained at one, because the decoder and demultiplexer operations are obtained from the same circuit, the enable input that makes the circuit demultiplexer. Decoder itself can be used as an AND, NAND, or NOR gate. Is that? So I hope it's making sense that how the circuit's output can be work in different conditions. Remember that thing. The decoder and demultiplexers can be constructed together. The large suppose in like is in the previous lecture, we discussed that suppose I want to increase the decoder size with the help of a lower size of decoder IC MSI circuit. At that time, we can use it the number of decoders. So in this case also, suppose I have a demultiplexer and I want 1 to 16. So at that time, 1 to 82 multiplexers are required. Okay. Now the truth table of this circuit is if E equal to 1, then all outputs are 1 because the outputs are equal to 1. Whatever the A and B. If A and B 1 1, then D3 is equal to 1, remaining all are 0. All are 1. So it depends on the D3. Similarly, if E equal to 0, because this is the NAND gate, NAND operation. Okay, so if equal to 0, then particular one line is 0 because the AB is 0 0 equal to D0, and remaining all are 1. So if equal to 0 and the selection line is 0 1, so D1 will become 0. In AB equal to 1 0, the third line yani D2 is equal to 0, and if AB equal to 1 1, the fourth line is equal to 0. So D3 equal to Dn equal to E if AB binary value is equal to A. Select by the value of AB. Decoder and demultiplexer circuit can be merged to larger circuit. Only the enable can be disable or enable depends on the logical circuit. The bottom decoder outputs are zeros and the top 8 outputs are generated min terms. So remember that thing, while the output of the top decoders are all zeros. Now here the question is arise where this circuit can be used logically. How this type of the logic can be implemented practically in our life. So I hope you all are aware about the EPBX system. EPBX is a telephone system which is used in big company or organization, where at the reception side there is a telephone line, and there is a different extensions are there. Suppose D0 is the extension of manager, D1 is at the clerk, D3 is at the cashier, and D3 is at local department. So receptionist here sitting and first ask that whatever the incoming call. Suppose incoming call say that I want to talk with manager, then reception press 00, and this line will become connected to the manager side. Okay. If that whatever the incoming call is not for manager but it is for local department, so the receptionist press 11 and divert the call to local department, and remaining are disabled. Okay, so EPBX system can be like as a multiplexer circuit. There is a many way. Suppose here we are discussing that the internet modem and is connected with the different LAN switch. Okay, I hope all of you have a internet at your home, but in previous or in organization the modem switch is that when you just search in your modem, there is a number of outputs are there. So whatever the frequency of cable, it can be going to the particular line one by one, and it can be select by AB. But this AB is a clock frequency or square wave. So in square wave, it is normally select one by one, like I suppose A B, like in this way. So 0 1 0 1 0 1, this is the value of A, and B is 0 0, and 2 times 1 double of this compare with AB. So what happened? 0 0 at that time the line internet line is transferred to D0. Here it is D1, D2, and D3. So if my input frequency is 100 megahertz, it is equivalent 25 megahertz to divide in each. connection line. So in this way, we can demultiplex our input signal, input internet line to four different equal frequency, but using the clock, or you can say sequence generator. So in this way, the practical approach can be possible to use the demultiplexer in real life. I hope is that making sense how the different type of the application can be possible with the help of demultiplex. Have a good day. Take care.